What if I told you that the key to understanding climate change lies not only in the science of our natural world, but also in the realm of statistics? Quite intriguing, isn't it? This is where the fascinating field of geostatistics comes into play. Geostatistics is a specialized branch of statistics that focuses on spatial and spatiotemporal datasets. It's like a detective sifting through mountains of data to uncover patterns, trends, and relationships. But instead of solving crimes, geostatistics helps us understand and predict the complex behavior of our planet's climate. The first step in the geostatistical process is the collection and organization of spatial data. This might include information on temperature, precipitation, and atmospheric composition from a variety of sources, such as weather stations, satellites, and even drones. Once we have this data, we can start to analyze it using a range of geostatistical techniques. One of the most common techniques is variogram analysis. This tool helps us understand the spatial variability of climate parameters. In other words, it allows us to see how, for example, temperature or rainfall changes from one location to another. Next, there's a technique known as kriging. Named after South African mining engineer Danny Krieg, this method uses variogram analysis to make predictions about unmeasured locations. For instance, if we have temperature data for two cities, we can use kriging to estimate the temperature in areas between them. Lastly, we have spatial simulation. This technique helps us account for uncertainty in our predictions. By creating multiple possible scenarios, it allows us to assess the range of potential outcomes and their likelihood. So, how does all this apply to climate change studies? Well, by using geostatistics, we can gain a deeper understanding of the spatial patterns and trends in climate data. We can predict how different areas might be affected by changes in climate parameters. Furthermore, we can assess the uncertainty in these predictions, which is crucial for decision-making in climate policy and management. Geostatistics also plays a pivotal role in climate modeling and environmental impact assessments. It helps us simulate future climate scenarios, assess the potential impacts of climate change, and develop strategies to mitigate and adapt to these changes. In summary, geostatistics is like a powerful magnifying glass. It allows us to dive deep into the complex world of climate data, uncovering patterns and trends that might otherwise remain hidden. It helps us predict how our planet's climate might change in the future and how these changes could impact different areas. Most importantly, it provides us with the tools to assess the uncertainty in these predictions, helping us make informed decisions about how to respond to climate change. So the next time you hear about climate change, remember, it's not just about the science of the natural world. It's also about the science of statistics, because without geostatistics, our understanding of climate change would be much less complete.